All right, this is a problem similar to something you're going to get into your accelerated math. Um, and we call it the bridge problem. And it's a famous problem that will just kind of drive you crazy throughout the trimester, but it is something that we need to look at. So first, let's read this problem. In 1980, the Crow River was 32 feet below the bridge. Because of silt buildup in the river bottom, the river was only 14 feet below the bridge by the year 1996. What is the correct equation for the d, which is the distance of the river from the bridge, where t, which stands for time, equals 0 at 1980? Basically what that means is they're starting to count the time in the year 1980. The reason they would want to do this is they're trying to come up with a trend at which point, if the river continues to rise, at which point the bridge will be useless and not be above the water anymore. And so these are reasons why they would use an equation similar to this, okay? So what we need to do is we need to kind of think about what we have, because it surely doesn't look to me right now like we have any slope. I don't have any specific points. I really don't have anything. What it's wanting me to do is it's wanting me to make a coordinate, okay? And that coordinate is going to go something like this. You're going to have a time and you're going to have a distance, okay? I want to list my time as my x coordinate because it's my independent variable. My distance is my dependent variable, or my y variable, because how far above or below the bridge is for the water level really depends on what year it is. The water level is changing by time, okay? As time passes, the water level passes. And so you need to have the distance as your y because it's dependent on time, okay? So that's why we're listing it that way. What I have right here really and truly is two coordinates. I have one coordinate that comes right here in the year 1980. The bridge was 32 feet, or the water was 32 feet below the bridge. And then my other coordinate would be 14 feet below the bridge in the year 1996. So it would look something like this. The problem is it gives you this handy dandy little thing right here. And it says, let time equal 0 be in the year 1980. Basically, that's where you're starting to count the time. So instead of calling this the year 1980, you are going to call this year 0 because that's when you're starting to count the time. So this is a coordinate that goes like this, time and distance, okay? And then for the year 1996, what you need to know is how many years past 1980, because that's where you started counting time, is it? So this is 16 years after 1980, and the water is 14 feet below the bridge. These are now the two coordinates that you're going to use, okay? And you're going to think of still using the equation y minus y1 equals m times x minus x1, because that's what you use when you have two coordinates. The first thing you're going to do is start by finding the slope. And again, the slope would be the difference in the y values over the difference in the x values. So my slope would be 14 minus 32 over 16 minus 0. So 14 minus 32 is negative 18. 16 minus 0 is 16. And that would reduce, of course, to negative 9/8. Okay, that is your slope, or your m. Okay, then you're going to use either one of these two coordinates. It doesn't matter which one you use. I would choose to use this one because it's a lot easier. But I'm going to use that coordinate and I will plug it into this formula. So y minus y1, which is 32, equals my slope, which is negative 9/8, times x minus x1, which of course is 0. If I simplify this, that's what I have right now, and then I will move that 32 over to the other side. I should have probably shown you that, sorry, to get to this point. So this is your equation in y equals mx plus b form. But remember, we aren't really using x and y's. Instead of x's, where we used x and y's, up here, remember, we had t's and d's, okay? So what was an x is a time, and what was a y value is a distance. Okay, so I'm going to replace those variables. My y was a d, my x was a time, and then they might not have it written like this. They might, or they probably have it written in function notation instead and use f of t to do this. What that means is that the height of the water level is a function of time. That's all this is saying. In order to find the height of the water level, I need to know what year it is. And if I know what year it is, I will plug that year in here and take it times -9/8 and add 32, and that will tell you how high the water level is in any given year. Okay, so that is the famous bridge problem.